Hello, are you guys back? So most good guys back, and how many people back? 34. We got us 26 people here. 3 are not. 2 are not sure. 3 body here. Mine's not. Okay. We continue goes with our code. That would be I think a bunch of code questions. Maybe at least 4 or 5 on your exam. DC arc for circuit, solar photovoltaic system with DC circuit, maximum voltage 80 volt or greater shall be protected by DC arc for circuit interrupter or other equipment provide equivalent protection. Because nowadays arc for is especially DC arc for, it's a pretty important things to go on. Oops, this is a rapid shutdown. This is a very important things. Photovoltaic rapid shutdown should be provided for system installed on or in building where the source or output circuit, insulated conductor cable installed on or in building more than 1 meter from the array. I think I mentioned this when we're talking about photovoltaic. It's for the protection of the firemen, because now you can see the photovoltaic circuit, they can go very high voltage. If rapid shutdown subrule 2, rapid shutdown shall not be required for ground mount photovoltaic system circuit. Enter a building whose purpose of housing those system equipment. 3, photovoltaic rapid shutdown shall limit photovoltaic source or output circuit located more than 1 meter from the array to no more than 30 volts within 30 seconds of the rapid shutdown initiation. That's why within 30 seconds, you can cut down the voltage to below 30 volts. So that's a safe voltage to handle. So this is a very important rule for the rapid shutdown. If you get this wrong, you're gonna get hurt really bad. 64, photovoltaic module bounding, subrule 4. The connection to photovoltaic module shall be arranged so removal of a photovoltaic module from a source circuit does not interrupt in the bonding conductor to other one. I think this one I show you the picture. Smaller wind system. So insulated conductor, supply wiring insulated conductor or cable from a wind turbine should have an ampacity not less than 125%, maximum rate current of the generator. Conductor or cable shall have a temperature rating of not less than 90 degrees. Let's try something. A smaller wind turbine. Let's see, is have 30 kilowatts rated voltage, 240 volts, 3-phase. So first, find out rate current of the wind turbine. Two, minimum supply conductor ampacity. Three, find AWG number of the wire. You guys want to give a try? Copper. The code book said if it didn't mention, by default, it's always copper, right? Okay, so a bunch of you have the right answer, and some other people at the beginning made a mistake. Hmm. Depends on the requirement. So the cold side, you have always use 90-degree conductor. And the minimum temperature rating is 90 degree. You could possibly. So if the equipment is rated for if no because we need 90 amps, if no requirement, we can go number 4. If we say, okay, the temperature rating is 75, then you'll have to go next size larger. And you can have 240 volt 3-phase. It's pretty common in industrial. You have a 240 volt 3-phase on-ground 3-phase system. I think if no mention of the temperature, if you look at section 4, it tells you depends on the amps. If more than 100 amps, you will go with 75 degree. If below, you will go with 60 degree. That's if they talking about the termination temperature. The part 3 is asked for the size of a conductor. Okay, you will see those one is almost the same when we go to large wind system. Also, supply wiring conductor cable capacity not less than 125%. Insulating temperature rating not less than 90 degree. That's a very common requirement for any type of generator. Same thing for micro hydro. Capacity not less than 125%. Insulating temperature not less than 90 degree. Hydrokinetic 64602. Same thing, insulate conductor, supply power to hydrokinetic turbine, ampacity not less than 125%. Be careful, sub-rule 4. Notwithstanding rule A-102, A-102 tell you the voltage drop. A voltage drop now exceeding 10% in the conductor between the electrical generator and the input of power electronic input shall be permitted. So because a hydrokinetic system, you have those type of system installed under the water, either in the river or in the ocean. And your power electronic system usually will locate a little bit farther away. So they allow you to have a larger voltage drop allowance, because usually you just got 3% or 5%, but in here, 3% for the feeder. In here, as long as you're not over 10%, you should be fine. 64604 stand-alone system. The diversion load shall be rated to a minimum 100% of insulated capacity of a hydrokinetic power, because this conductor, insulated conductor for those cables, the hydrokinetic system, your cable is submerged underwater. So usually they didn't mention any temperature rating down here, I think. So under the water, you're not gonna have a temperature really high. Not like other type of generator, you're gonna be require 90-degree rating, and those one usually probably you're just gonna use underwater cables, so they now require 90. If they ask you to do the calculation, but probably for this one, because they didn't ask you that, and they probably only ask you the conductor ampacity. Unless they specify what's the terminal voltage, then you're gonna pick based on that. Termination voltage, you're gonna base on that. I think we are here. Stand-alone system. The diversion load shall be rated to a minimum 100% of installed capacity of a hydrokinetic power system. It protects unless otherwise specified by the manufacturer, because you might be have those hydrokinetic stand-alone system. You have a totally no load connect on there, and your generator is pushed by the water, so always generate voltage and the power. That's why the diversion load for hydrokinetic have to be rated minimum 100%. Stationary fuel cell system. Marking, permanent marking shall be provided with rule 2-100 at the disconnect mean. Specify the following additional information. So 200 will ask you to have a certain marking on disconnect mean, but you also have to add those overcurrent protection value and the short circuit current interrupting capacity of the protective device. Brief system description. That's for sub-rule 1, sub-rule 2. The location of a manual fuel shutoff valve shall be marked at the location of primer disconnect means of the building or circuit supply. Because if anything happens or something goes wrong, you have to know where to shut off the fuel. You don't want to keep feeding the hydrogen fuel into the building. It might cause fire or explosion. Electrical equipment. Transformer installed in room contain fuel cell power system shall be the dry type. So if you have a oil-cooled transformer with the fuel cell together, that's gonna be a big trouble if you ever catch on fire. Area provided with mechanical ventilation required for the safety during normal operation shall be interlocked to provide alarm or shutdown of the fuel cell power system upon loss of ventilation, because you don't want the hydrogen gas to accumulate inside the area. That's why you need a mechanical ventilation. And if you lost the ventilation, you need to provide an alarm and shut down the fuel cell. Indoor installation of fuel cell power system that are fueled by a gas that has not been orderized shall have an automatic shut-off valve located outdoor that's interlocked with the indoor combustible gas detection. Where automatic fire suppression system provided for the fuel cell system, it shall be interconnected to shut off the fuel supply when the suppression system is activated. So that's the fire suppression system. I think next one you guys gonna learn those things next week. It's for, because those things is try to push the oxygen out from that room. So or it's try to push the hydrogen outside that room. But if you activate that fire suppression system, you still have the fuel in there. You just totally destroy the function of that system. Storage batteries. Storage battery for dwelling unit shall have the cell connect ISO to operate less than 50 volts nominal. So for industrial use, doesn't matter. But if for residential dwelling unit, you cannot higher than 50 volts. It's for the safety of the people living down there. Lead acid storage battery for dwelling shall have no more than 24 2-volt cell connected in series, so 48 volts maximum. Life parts of battery system for dwelling unit shall be guarded to prevent accident contact by person or object, regardless of voltage and the battery type. Because battery can supply large current, so even it's a low voltage, you have to guard those life parts or prevent the accident contact. So people not gonna accident drop any kind of metal parts on top to short them. Diversion charge controller. Circuit contain a DC diversion charge controller. A DC diversion load should comply with the following. The current rating of a diversion load shall be less than or equal to the current rating of the diversion load charge controller. So because if you have a larger load than the charge controller can control, you're gonna damage the charge controller. The voltage rating for the diversion load shall be greater than that maximum battery voltage. That's pretty common. The power rating of the diversion load shall be at least 150% of the power rating of a renewable energy system. It's just for the DC system. Sometimes you can have a certain thing happen if you supply or charge controller, you will be over supply that, so you need to have the diversion load 150% the rating of a renewable energy system. Also the next one, The conductor ampacity of the rating of overcurrent device for the circuit shall be at least 150% maximum current rating of diversion charge controller. So because your conductor also can supply more current, that's why your your diversion load also have to be rated for 150%. So C and the D is kind of matching together. Okay, so main thing is section 64, but if you ever go to the real job, you should know on section 84 or 86, let me see. 84, I think. Oops. So 84 is interconnection of electrical power production source. This is where I think when we talk about in the BC Hydro's interconnect requirement, they refer a bunch of things from this section. This is talking how you're gonna connect your renewable energy system to the utility supply. So you're not gonna have the exam question came from this section 84, but if you go to the real job, you should be careful. Is lots of things is referred to and set up by this section 84. You can see here the anti-islanding requirement. The means shall be provided to isolate equipment that's energized from both directions from all on-ground conductor of each source of supply. So you should be aware that section in here you need to know, but I'm not going to test you on this section 84. Okay, so that's all the code for this renewable energy system. The main thing is section 64. And I think that's all the material I need to show you. Now it's 12:06. The rest of the time, I will just leave for you if you want to study anything or you have any question. Not too much because section 84, they just have those very general rules. I barely heard people mention anything on 84 on the IPs. Mostly, I heard people said the IP question came from section 64 relate to photovoltaic panels, the installation. So one question for sure, I already told you. Other question, people said mostly is those new rules add on section 64 for the PV panel. So if they have any rules, usually mark with a triangle, a delta signs, that's type of the question you're most likely to get on your IP for the renewable energy.
Hey, Jack.
Yeah,
Can I ask you a question that you might not know the answer, but you might about like uh, ITA?
sure, go ahead.
You know how they changed everything to harmonize so we could work like interprovincially, I guess. I think that was the reasoning they told us so that you could start your apprenticeship in Alberta, say, and then move to BC and work and go to school.
Yeah,
So,
that's the original intent.
but when you have, so if you get your ticket though, like, or say you become a journeyman, but you haven't written your IP, so then you can't go work in other provinces until you pass the IP.
I think the way is because before, but still Ontario they are not doing the harmonization. So what they try to do is if your apprentice you're working in BC for a year, you're taking the apprentice year level 1 training here, and if later on you find a job in Alberta, let's say, then you can continue your training in Alberta. You can go to Alberta for second year, and if you come back BC, then you can get your third year in BC. Then you go to Alberta for year 4. The original intent is like you can go anywhere to get your apprentice training if they all provide the same training, right? Then you don't have to say, oh, because in year 1, I I've been taught this in BC, but Alberta actually taught that thing in year 2. Then in BC, we taught something different than year 2. So when you go to Alberta, so if you're moving around, something you're missing down there. So they try to say, okay, we set the same standard. We're going to teach this thing on year 1, this thing on year 2, this thing on year 3. So it doesn't matter where you get your later year education, you still will get the same thing. But is that perfect work? Uh, no, because what I heard, I haven't got any really document or anything. They said that because Ontario, they got the big chunk of those apprentices or whatever, and they just want to do their own things. They don't want to go harmonize with anyone else.
So they changed all of that for two provinces, or I guess like, there's maybe a couple more, but not Ontario or not Toronto.
That's what I heard so far.
Huh, weird.
But maybe they change their mind or whatever, right? But the original purpose is every province can be good in that way. So who knows?
Yeah, fair enough.
Lucky, that's a really question. I don't like you to worry about that one. Because what they try to say is they said they have some idea. They said, okay, in the summer, you have more sunlight. Then you will have so you can use the PV more, and you will have a more calm day or whatever. Then you will have less wind. Then in the winter, because you in the winter, especially they talking about North America down here, right? North part of atmosphere. So okay, you have less sunlight, but in the winter you might have more storm or whatever. You will have a stronger wind. That's the original idea they try to get from that question. But the wind is actually causing by the temperature changing on Earth's surface. So in the summer, you actually the temperature on the Earth's surface because you have more sunlight, they receive more energy. Your temperature gonna changing rapidly between night and the day, so that gonna causing the wind. So one more thing you probably from our experience is like a hurricane in the East Coast down there. The hurricane is always happening in the summertime because the summer is so hot and the water from the ocean got evaporate so quick and they kind of like causing those storms. So that's why that question doesn't really make too much sense down there. So don't worry about that question too much. Oh, you're welcome. You don't have to thank me. From what I noticed, so tomorrow's exam, better get in there as early as possible. Don't wait to the last minute. From my previous class experience, they usually can finish the exam within, most people finish within an hour. So even I give you 2 hours, you're probably not going to take that long. Certain people can get about fast people, they finish the exam in a little bit more than half hour. Go through some calculations. What type of calculation? Code calculation? You have a specific question you want to ask me? Or you want me to make up some question for you? You want me to make an easy question or you want me to make a hard question? Hard one. Whoa. Looks like you're up for the challenge, huh? Okay. What test question? You will see the test question tomorrow. Case, so like I mentioned, you're gonna do some calculation for when talking about that, you will do the calculation from like heating the water with a hot water tank, those type thing. But I'm not gonna ask you to calculate something from ice to steam. But if you guys like, I can throw those type of questions here because maybe you guys just feel too bored. So here's the one question. I will meet you guys specific heat capacity. No, you don't need to remember the constant. I'll provide to you. Two wind turbine. Yeah, don't have to be wind turbine. Two micro hydro system. Micro hydro generator. Both three phase. One is 20 kilowatts and 240 volts. B, 35 kilowatts, 240 volts. You go to use same EMT raceway to connect to distribution panel. The panel have a termination temperature rating of 60 degrees. So I'm gonna find the minimum size AWG copper conductor for the 35 kilowatt generator. Okay, so that's the question for wind turbine. And if you case you still want the thing from ice to steam, if you want, I can make up a question down here. Okay, 6 kilowatt electrical hot water tank, 250 liters. City's incoming water is 10 degrees Celsius. The required hot water should be 80 degree for the process. So you're gonna find kilojoules for heating the water, kilowatt hours, energy required, and how long need to heat the water. Uh, 4.2 kilojoules per kilogram per degree. Oh, you got to follow the code. What's code required? So that's why you need to know the section 4, how they said if you need I haven't done the calculation yet, so I have no idea what size of the wire they need. Okay, let's see, 35. So far, I haven't seen a right answer for question 1 yet. Question two got a bunch of answers, so let me see. Question 2. Question 2, I can write the answer down. It's 6 kilowatt. So it should be 20.42 divided by 6. I got a 3.4. Eric, why you get a 4.03? Gotta read the question, right? Read the full question. I saw you guys' calculation. Steven. Okay. Steven, when you're calculating your ampacity, do you times 0.7 or you divide by 0.7? I think you guys gonna be in big trouble when you're doing the code. You forgot everything. Question 1. 35 kilowatt generator, rule 3, 240. Give you 84.1969 amps. So rule requires 125%. 84.1969. Give you 105.25 amps. Then how many conductor in the raceway? Six conductor, right? Because you have a 2 3-phase generator. So table 5C tell you 6 conductor. What's the derating factor for 6 conductor? 80%. So 105.25 divided by 80% or divided by 0.8. Give you 131.57 amps. Go to table 2. Not yet. Yeah, we can go to table 2. So termination temperature 60 degree. So you need to find out on table 2 at the 30-degree column, a conductor size to be able to carry 131.57 amps. Who said you only use 2 of 3 phase? You got a 3-phase generator, just gonna use 2 phase. So that will be give you a number about 2 odds. Only the 2 odds at the 60 degree will be able to carry this current. So you need a 2-odd conductor, but you need a 90 degree rated. So you either need RW 90 2-odd, or you need a TW 90 2-odd. Mostly you will choose that one. We have a bunch of conductor inside this raceway. The conductor gonna carry a current. When conductor carry current, do they generate a heat? So when they generate a heat, when you have more conductor, do they generate more heat? Yeah, that's why when you're derating them, you need to pick large size conductor so the temperature can cool down. Otherwise, they're gonna become too hot. Who said you cannot use if you have a here's your distribution panel, and you have a generator 1 down here, you have a generator 2 down there, then you bring them into a box. Those conductors cannot go into the same raceway. Yeah, divided by point A. That's why. The code only does not allow if they are different voltage, right? If they are the same voltage, the conductor for sure can go through the same raceway. No more. It's telling you how good with all the rules. You gotta put everything together. That's what you learned, right? And also another thing I usually tell my student is why we learn so many calculation, why we learn so many things is at the end is for you, all you have to do is on the job to figure out what size of conductor you need to pull in that cable or in that raceway to supply the load. That's why You have a three-phase calculation. You got to figure out the rate of the current. Then the rule tells you got to oversize your conductor, so you oversize your conductor. But then how many conductors in the raceway? You got to derate them. What's the termination temperature? You got to derating them. At the end, you just need to find out what size conductor you need, right? Because the purpose down here, why we need to supply this large conductor, because for this conductor to carry this current, it's not going to causing the temperature go over 60 degrees. If you pick a smaller conductor to carry this current, the temperature will go over 60 degrees. You're going to damage your equipment. That's why you learn all those calculations through year 1 to year 3. Come to the basic as an electrician, you just need to be able to pick the right size of conductor. So here's the distribution panel. This panel is rated for 60 degrees. And you guys on the job you saw, you might have a large size circuit breaker or anything. So if you're looking at here, you can pick any other conductor. Let's say for 90 degrees, if I pick number one conductor, we for sure to be able to supply that current. But if I just use the number one conductor in here, the number one to carry 131 amps, right? This temperature of the conductor will reach almost 90 degrees. If you reach 90 degrees, are you allowed to go into this distribution panel? You're going to damage it. So as Ted usually tell us is we as electrician, wireman, here's the equipment. Here's our conductor. We try to connect the conductor into the equipment. They, equipment manufacturer, they using part 2 of the code, right? They try to, because we usually use copper aluminum. Copper aluminum is good material to conducting the heat. So what they try to do is, because equipment, usually they have a cabinet, they have doors, they have locked enclosures, they carry electrical current or whatever, they're going to generate heat. They will have heat build up in there. They try to use our conductor to carry the heat away. But we as electricians, we pick a conductor to carry the current. We also generate heat down here. We try to bring the heat into the equipment. That's where the conflict starts. So now, before, when I go to school that time, we don't have those kind of different temperature degree, or at least we don't have that 4-006 to talking about we have to looking for what's the termination temperature for the equipment. All we have to do is we go to table, we say, okay, 90-degree conductor, whatever the amp we can carry, use that. 75, whatever that carry, we can use that. But then that's where the conflict came from. So in about 10 or some years ago, we started adopting where the NEC is the code, National Electrical Code, they taking from the states down there. They have this thing because most equipment is built down there. So they said, okay, wherever your conductor is here, if the equipment rate for 60 degrees, then when the conductor carry the current, you cannot generate a temperature higher than 60 degrees. So if we're using this number 1 conductor to carry that 131 or 32 amp, for sure, you're going to generate a temperature higher than 90 degrees. So you're going to go to 60-degree column to pick a conductor to carry that current, not going to have a temperature higher than 60 degrees. But then the code requires for this type of the microhydro system, you have to use 90-degree rated conductor. So you pick based on 60 degree, but then you're going to use 90-degree rated conductor. Yeah, so Shane, you answered that question right. Case now makes sense to you? You pick the size based on the temperature rating of the equipment. But then you're going to use 90-degree rated conductor. And then we give it to you. Where did you go for your temperature limitation? Equipment marked with maximum conductor termination temperature. The maximum size of conductor used shall be based on the allowable ampacity in the temperature column. The calculation part in the code book, the calculation part. That's the table. So you're going to pick based on your 131 amps, which 60-degree conductor can carry 131 amps. Not going to causing the temperature go over 60 degree. No, 2R. 2R is 145. So 2R will be able to carry 145 amps, then still at 60 degree. When I teach year 1 or year 2, I always ask people to highlight table 2, copper, 3, conductor, temperature 30 degree. So you better have those in highlight. Table 4, aluminum. And also, when you're doing the code exam or anything, a ruler is very good, because if you put a ruler down there, it's very easy to find, especially if you look at the table D3. The table D3, if you don't have a ruler, you try to pick the amps and the conductor size. It's very easy to go to different column. So a ruler will help you to do those things. Should we take a break? Yeah, you guys don't need a break. I'm gonna take a break. I'm a slave driver. You guys gonna finish everything. No break for you. Slave driver. Now it's 48, 103. I don't have anything new thing to show you or to teach you. If you want to just working on yourself, you can leave now. You don't have to stay here. If you have a plan how you're gonna study and but I will stay here to 2. If you have any question, you can always come back, or you can just mute or unplug yourself until you have a question. Then you can come back to ask me. Yeah. Yeah, no problem. Oh, I'm not the best. I'm the worst. I always bully my student. Yeah, no problem. Okay, see you guys. So that's the answer for second question. You guys all okay with that one? Hello, anyone here? $250 equal to 250 kilogram. I gave you that, right? Yeah, don't make that mistake. 250 kilogram times 4.2 kilojoules times, I think, the temperature required is 80.
Yeah, the change of temperature is 70.
Yeah, so change the temperature is 80, subtract 10. That will give you the answer, I think. That would be the answer I give to you. I forgot what's the number. Getting old. Sorry. 73500 kilojoules. Then to converting that number into kilowatt hour. $20.4 some for 2 kilowatt hours and 20.42 kilowatt hour divided by 6 kilowatts, 3.4 hours.
Sorry, where did the 6 kilowatts come from?
I gave it to you. The 6
okay.
kilowatt heater.
Gotcha, okay.
Yeah, that's right. So you guys know tomorrow afternoon, no, still morning. Tomorrow we're gonna start emergency power at 11:30, right? Yes, don't be late. Kind of wondering who's always skipping my class. Maybe I should take attendance. Yes, no. Yeah, because usually I just saw 46 or 47 people here. You skipped this morning? Oh, no problem. Yeah.
Jack, to be fair, I think you did say earlier that it was up to them if they wanted to stick around. Maybe they just went to do their own thing.
No, now. I mean, like even in the morning.
Okay.
No, it's okay. If you have those medical appointment or something, totally understand. Oh, you think I'm a good man? Sometimes people call me evil. Yeah. If you've been in my class, you shouldn't be feel too bad for this exam. My idea is I'm here to show you, to teach you something. So if you come to my class, you listen to me, you should pass the exam without problem. The best way is yeah. So the majority of the question will come from your working sheet and from the PowerPoint. Like not gonna be the majority thing from there. And there's a few things I showed you during the class, wasn't on a PowerPoint, but there's some related calculation question in the what should I say, in the working sheet. Uh, the 4.2 we're always giving to you. That's the specific heat capacity. And 80 subtract 10, that's the difference between temperature. Yeah, that's the delta T. They both have the advantage and disadvantages. So I think I have some picture I can show you there. Just give me a second. Where's my evacuated tube picture? Yeah, doesn't matter. I can just Google a picture. because the evacuator tube, let me share a picture with you. So this is the evacuator tube. They have a vacuum inside there. This is the heat absorbing plate. The plate gonna absorbing the heat, then transfer to the heat pipe. There's some liquid in there, and the liquid gonna be become vaporized to rise to the top. This is a flat. They usually don't mount flat. They mount in an angle. When they reach there, here is your like a solar solution. They're gonna circulating through here, so they're gonna take the heat from this white vapor, which is heat up to there. In the cold climate, because here is the vacuum inside, so they receive the radiation heat, but they cannot conduct or condense those heat out. So they can keep the heat inside to heat there. If let me see, they usually mounting is this picture show you they mount in an angle. So those in the liquid inside, when they heat up, they can vaporize rise to the top. Then when they cool down, they will flow down to the bottom or to get heat. The picture before I showed you, I think doesn't matter. This one is also good looking. So they can install each one individually, stuck into that heading down there. So basically, you mount the top part first, then you can stuck each tube like this one. You install each tube in there, then you mount them. So it will be easier to the installation, and they're not gonna be so heavy. But for the flat panel, the flat panel is the whole thing together. So this is a pretty good picture. This is where the solar thermal solution come in. Then because they come in this way, and they're gonna rise to the top when they go through there. Those heat collector gonna be heating those solar solution inside. Then they go out from the top. But there is no evacuation inside. So they are absorbing the heat, but those heat can also conduct through the air to go out. So in the cold climax, the evacuator tube will be better. Also, this flat panel, everything was installed together. You cannot separate them. So when you install them, it's heavy. It's not easy like the evacuator tube where you can install each one individually. But the evacuator tube, because they need that vacuum to keep the good heat insulation, that vacuum over the long period of time, maybe 10 years, 15 years, they will gradually reduce and they will need to be replaced. Also, because those one, they use the glass on the outside, and we know if you're handling glass, you have to be careful. Otherwise, they're going to be damaged easily. But the flat panel, it's not glass, so it's much tough handle. They can handle in more abuse. Thermal volume expansion on slide A. Which one? The one we call the solar thermal? You mean this one? It's anything like except the water, right? Water, when you cool down below 0 degree, become ice. The volume will actually occupy more volume than the water. But so as the water, but if you compare water to water or anything else, when the temperature increase, they always gonna be either the, let's say, the atom or the molecule inside, they're gonna be more active. So they will kind of expand a little bit. For that reason, because you need to have enough solar solution or, or heating solution inside there, like a mixture of water or glycol. When at the nighttime, they might not be occupy all the space inside, but you still have to fill them up. But when they got heat up, because this one can heat up if the temperature rise, good sunlight, they can increase the temperature a lot. When the temperature increase, they will be. I'm not sure if you guys did in the code section. You even on the code, there is talking about when you have a PVC pipe connect together, right? After certain length, you're gonna put an expansion joint in there. So even a solid piece of material, when it warms up, it will expand. So those water or glycol inside, they will try to expand. But when something expanding inside, they're going to increase the pressure. That's why this expansion tank is, if you have actual volume, they're going to stay in the expansion tank. And if the temperature getting lower, because you install those things on top of your roof, in the winter, you might just get 0 degree or below. In the summer, you might reach 30 or 40 degree. So the big temperature difference will causing the volume to change. So you need to have actual something in there to hold those things. I think in section 12, when they're talking about PVC, you guys probably did that. Rigid PVC. Rigid PVC, you guys usually we do expansion calculation. So this rule, expansion joint, if you go to appendix B, 12.1118, so they tell you different material. We have this is a linear expansion, but the volume expansion is almost the same, right? So you got to figure out how long is the material and what's the temperature difference, and what's the expansion rate. That's where you're gonna leave the room for that thing to expand. Even on a bridge, right? They usually have a gap, put a metal plate on top. That's also for the expansion. Or if you're ever looking at a large building, long building, yeah, like a SE1 in BCIT, in the center stair there is a gap in between the concrete building, and the gap down there is for the building to expand and contract. Yes. So here talking about discussing between the flat panel and another one called evacuator tube. The flat panel have a high ratio about absorbing play area to total collect area. The tempered glass is very strong, able to withstand hailstone. They don't require long-lasting vacuum seal to maintain proper operation. They are more heavier and require proper support structure. They are not as efficient as evacuator tube collector in very cold climate. Evacuated collector retain heat better than the flat panel class. They are light during installation, but the glass tube is not as strong as the tempered glass, so it can be damaged by a hailstone. They must be mounted at a minimum slope, 25 degrees, to allow proper functioning of the copper heating pipe. So that's a kind of like a BCIT's notebook I try to write for this course. We haven't finished yet, so maybe next term or sometime, if I finish, they will probably print them out so student can have them. Yes, because they are semiconductor material made. The lower the temperature, the higher the output voltage, and the higher the output power. There's three factors gonna deciding that. One is cell temperature, one is the irradiance, another one is the load impedance or load. They have to compare in the same category. So if you increase the solar irradiance and compared to low solar irradiance, you will have more power. Then if you have a higher temperature compared to low temperature under the same solar irradiance, the low temperature will have more power output. But if you're talking about, at the different, if your panel in different solar irradiance and a different temperature, you cannot compare that. But for the same panel, we think the solar irradiance is the major deciding fact because you need more sunlight to providing the power. Even that increasing sunlight will causing the temperature increase, but the temperature increase will be causing decrease in power. So the whole thing will be just like it's easy to see in a mathematical relationship. So if your x equal to 5a plus 2b plus 1c, right? So if A is the solar irradiance, let's go subtract 1c, or C is the temperature. When you compare those things, let's say B is the load impedance. We know you increase the solar irradiance, you're going to get a large X, but at the same time, your A and C have a kind of relationship. If your A increase, your C going to increase, going to causing the output become lower. But this is if your A increase 1, your X can increase a large number, but your C increase, you're going to cause it to changing in a small value. MPPT is related to how to compensate for the load impedance. Is to get the best related to load impedance. That can get the maximum output, maximum available power. MPPT is try to get the maximum power from the panel. But at a different time, the maximum power available, it depends on the solar irradiance and the temperature. So this number is not a constant number. Any of those changes, we change the power available. But the two things you cannot control. One is the solar irradiance. So all you have to do is you got to make sure there's no shadowing. The load impedance depends on if you want to charge a 12 battery, or you want to charge a 6-volt battery, or your load is require 120 volts, those type of thing. Or if the load is in your house. Yes, you mostly you will put enough PV panel. You look at the power to matching the requirement. Then you will put those panel either in parallel or in series to build an array to connect to your either your charge controller or your inverter. But then, because how many power you're using down there, you're gonna change your inverter output. If you don't have the battery, then the demand in here gonna change the load impedance. That's why we usually put in a battery down there. So you can always charge the battery from the battery to your inverter. This will be a pretty steady load, but also the battery may be over discharged or fully charged. You're also going to change this. I think you, so in third year, I think you learned square cage induction motor and round rotor motor, right? You can just thinking a single feed induction motor as square cage induction motor, and the double feed induction motor just as a round rotor motor. I wouldn't call them which one is more efficient in power, but which one is simple in control of whatever to use, which one is more common to use. So they are both motor or they are both generator. Yeah, so your single feed is compared to a square cage induction motor. It's much easier in construction because you don't have to have the rotor winding or connection. You just use a square cage inside. But you run the rotor motor, you have to have the rotor winding, you have to have the slip ring, you need to have the outside. Even when you learn that in motor controls, you run the rotor motor control will be much more complicated than the single square cage induction motor control. The speed does not affect the power output. The speed only affect the frequency and the voltage output. Just like we did a calculation down here, right? This is double feed. So you need to put a 15 hertz into the rotor to make the output matching with the grid. Yes. So if you're just using a single feed induction motor 4-pole, if they only running at a 1350, they will only give you a frequency about a 45. So when the wind speed pushing the rotor running at this speed, they only give you this frequency. To make that to 60 hertz, for this duplicate fed, we put a 50 hertz into the rotor to make the output at 60. But for single feed, because there's no way we can adjust it, so we just put that 45 hertz AC, we change it to DC. Then after change to DC, we're gonna invert it back to 60 hertz. That's the difference. Yeah, sometimes just a little bit of something caught there. It's not related to power. It's only related to this frequency. Yeah, I probably misunderstand you before, so I couldn't explain that one to you. Maybe you ask me this thing, I try to say something else. But finally, we solved the problem. That's the good thing. Yeah, you're welcome. Uh, the Scrum question always relate to the online quiz. So if I can do the online quiz, that would be where the SCORM question came from. No problem. Yeah, you're welcome. Hayden, you better get a good mark tomorrow. Otherwise, I'm gonna come to your home to see you. No threatening. Okay. You guys have any more questions? Any tip for the exam? Have your notes, do all the work, get the working, do all the working sheets, try the online quiz. You should get a pretty good mark. You have a lot of time for this exam, so don't rush. Read all the questions. Yeah, that's the SCADA for monitor all the turbines or the controls, just monitoring the controls in the micro hydro generator. SCADA will be more wide, broader term for it's for supervisory and the data acquisition. So yeah, Yes.
Hi, Jack. I have a question relating to the worksheets.
Yeah.
Just there's a question about a hang on, I've lost it. A generator. What is a complex? No, hang on. Where is it? Yeah, here. What qualifies as a complex distributed generator? I don't know where that comes from.
It's in one of the working sheet.
Yeah,
Which working
the
sheet?
renewable energy worksheet.
It's all called the renewable energy working sheet. Which one?
Yeah, it's micro hydro, hydrokinetic fuel cell, and grid tie.
Which question?
So it is question 30.
Question 30. What qualify as a complex distributed generator? So, where do you think where this question came from?
Oh well, from the code.
From the code or from the BC Hydro's interconnection requirement?
Ah. Okay.
Okay.
Yeah, I actually printed that out so I can have a look. Or no, I don't know if I have the interconnected document.
It's online. Also, I think Case sent out a document to you guys. Yeah, that document for sure is online. On D2L, you can find that document.
Yeah, this is the BC Hydro Distributed Generation Technical Interconnection Requirements, that document.
Yes.
Okay, I got it. So we'll get questions on the test from this document.
What do you think?
Yes. All right, thanks.
You're welcome. Okay, if you guys don't have any questions, I'm gonna end the meeting.
All right, thanks, Jack.
You're welcome.
Yeah, thank you.
No problem. Okay, see you guys tomorrow afternoon. Good luck for tomorrow morning's exam.